Hi, this is Terry Iverson from CNC Rocks in Champion Now. Today we're going to talk a little bit about the manual milling machine. Milling operation is predominantly to make flats on parts and drill and tap holes on parts. You can do round parts, but then you'd need some sort of a rotary product to rotate the part, and we can talk about that on another segment. But on the manual milling machine, you have 3 axes, unless you have a rotary product. This is the table of the actual milling machine, which would make sense, just like a table in one of our homes or in our office. And the table has T-slots in it, and this is how you fixture or hold items onto the actual table of the machine. You have the T-slots that will locate it. This table is called the X-axis, and X is side to side. So you have handles that will move the table underneath the center line of the spindle. This is your spindle of the milling machine, which will rotate, and you'll have an R8 collet that'll hold your tool. Now on a lathe, you'll have your part in a spindle, but on a mill, you'll have your tool in the spindle, and the part will be located on the table. So your handle here allows you to manually move the table back and forth so that your part will be located under center line of the spindle where the cutting tool will be rotating. You also have Y axis, it's a second axis, and Y on the table will move you in and out from the column. This is the column of the milling machine. So you'll be able to move it this way in Y, the table, and the table in X. There's also such a thing called power feeds. Remember, we've talked about how literal all the definitions are of the terminology. Power feeds puts power to the feed rate, or gives you a feed rate, so that you don't have to manually rotate the handle. So this handle is for the X axis, and it's connected to a lead screw. And the lead screw, there's a nut that attaches to the table, and then the nut and the lead screw collectively connect to each other, and then as you rotate the lead screw, same thing on a lathe, the actual nut will be attached to the table and it'll move the table as you rotate the lead screw. So you can have a power feed, which once again, definitions in our industry are very literal. It'll put power to the feed of the table, either in X or in Y, and so that'll allow you to have power feeds on the table. So a lot of manual milling machines, that'll be an option that people will many times have on the milling machine is a power, servo is a type of power feed that allow you to enable the feed rate and adjust it on either Y or X. This is called the knee of the milling machine. And so the knee allows you to bring the whole assembly up to the spindle so that you can bring a heavier part closer up, because on your quill, this is your quill of your spindle, your quill is only going to allow you to go so far in terms of a travel. You can see here's your quill, and this is a quill lock, so you can actually lock your quill down. So there's 2 ways of either bringing your part up to the spindle or to the tool, or bringing your quill down. Case in point is different parts you'll want to do it in different manners or different ways. But this allows you to bring your knee up to the cutting tool that's in your spindle. So this is your knee. And you can put a power feed on your knee as well, on the knee component of the milling machine. So that being said, when you have a part, you'll fixture it in the T-slots on the table. You'll have a tool in an R8 collet, most commonly R8 collet. And then you'll actually get to the point, I'm going to release the clamping on the quill so it'll come back up. And so you'll actually actuate, here's your spindle motor up here, so either in forward or reverse, I don't have it powered on right now, forward or reverse, you'll enable the spindle to rotate, the motor's up above, and then you either have the machine in 230 volt or 460 volt, and then your cutting tool will rotate. This will allow you to cut steel, any metal, any type of plastic, in some cases even wood. So then you'll bring your cutting tool or your drill, because you could have a drill, down to your part, and actually machine the part. If you want it down in a particular location, let's say you had an end mill, you can clamp your quill in the down position. Then you can actually have an end mill where you'll feed the end mill side to side. You could have power feed or manual feed with your handle, and then you'll bring your cutting tool down to a certain depth of cut, and then you'll feed it either manually or with a power feed through the part. So you'll put a slot, or you may actually cut the top of the metal component or whatever material it is to bring it to a certain height or certain thickness. So the other thing, this is called a depth rod or depth adjustment for the quill, and you can set this. You can see here's a stop, and you can bring it down so that it'll stop at a certain location. So if I want it, at a certain location, I can adjust this. Now in some rotary products, there's small programmable rotary products, which we'll talk about that again in another session, that'll index, that will have a little control on it. And you can put a micro switch right here so that when you come down, or pardon me, when you go back up, there's a micro switch that clamps on here that'll actuate the control box to index the part. So that if you're doing a hex or you want to do multiple sides or a square, you can program the indexer to index or rotate every every 90 degrees, every 60 degrees, or whatever fashion you want, so that after you come down and say drill a hole and you come up, you'll hit this micro switch, it'll index the component, the part, so that you can then come down and do the second operation. It's a pretty slick way to do it. But once again, we'll get into programmable indexing fixtures and indexing heads in another session. So you actually have the ability to feed the quill down as well. And there's different controls. You have a handle here to adjust your feed rate. Once again, we talked about turning the spindle on. You turn it on and forward, and you can adjust your RPM. Remember, you have revolutions per minute, which will give your cutting tool what RPMs you want to cut at. Usually the bigger the tool, the slower the RPM. The smaller the tool, the higher the RPM, just in general. So you can adjust your feed rate in this fashion. In addition, on the manual milling machine, you have a draw tube up above here. I'm too short to reach it. Many times that's one of the things that people will, on a manual milling machine, they'll have a power drawbar. Keep in mind you have a collet, an R8 collet, in the spindle, and it holds on to the cutting tool, right? Remember, on a mill you have cutting tool in the spindle. On a lathe you have the part in the spindle. So the collet will have to draw up to clamp onto the cutting tool, and that's what a drawbar is, which is way up here. So for us shorter people, we'd probably need some means of getting up high enough with a wrench to be able to engage that manual drawbar. Otherwise, many times different people will buy machines with a power drawbar where you'll have a button to push to open and close the collet with the drawbar. But on a standard milling machine, which there's many makes and models, that's usually how you'll engage, is with a manual drawbar. You'll just need a step stool for us short people. Once again, there's coolant. There's a coolant hose and a coolant line, so we can engage coolant. Cutting fluid cools the tool or cools the part, just like on a lathe. And that gives you a little bit of an indication of the basic operations of the manual milling machine, what you would use it for, basically some of the basic controls, basic terms, quill, spindle, table, lead screw, X, Y, and Z, or X, Y, and knee. And of course, in Z, you're going to have two different facets. You're going to have a spindle that can come down and a knee that can come up. So, keep that in mind, that you actually have two means in one axis, coming from the bottom up and coming from the top down. One involves the tool, cutting tool, while the other involves the part or the fixture. There's one last thing I was going to point out, and that is, just like on a lathe, many people will put a digital readout. We probably, if you looked at the lathe segment that we filmed, a digital readout actually gives you location, and you can have your X axis on a digital readout with a scale, and then you can have your y-axis on your digital readout with a scale. And then once again, there's two different means of axes in Z, the knee and the quill. So you can have a scale on the quill or you can have a scale on the knee. And usually end users that use milling machines will choose one or the other. More commonly it's the quill, but occasionally some people will put power feeds and digital readout scales on the knee as well. So I hope this has been informative. This gives you a basic introduction to a milling machine. There's many milling machines throughout the country and throughout the world in shops, from prototype shops to production shops. And I hope this has given you an introduction to milling, and we'll talk further concepts into CNC further into our sessions, our segments. You can put a CNC control on a manual milling machine as a retrofit. So instead of power feeds, there'll be servo motors with encoders, and usually it'll be on X and Y and occasionally on Z as well. If it's a X and Y, it'll be a 2-axis CNC retrofit, and if it's either on the quill or on the knee, that would be a 3-axis CNC retrofit, and you'd have a full CNC. On milling machines, there are such a thing as a 4th axis, back to the rotary product, and on machining centers, which we'll talk about that in another segment, the rotary is the 4th axis. Occasionally, not always, you'll see a CNC milling machine retrofit with a 4th axis, but many times they'll have a semi-4th, which is just for indexing. So I hope that's been informative, and I appreciate you spending time learning about milling equipment today.